how we use the AI to build faster, sell more, and support better. All right, so we're going to hear from 4 colleagues here that have been doing great work. So as you can see here, if you're fast enough, we're going to talk about learning, vector search, and a couple of cases for customer support, and most importantly, your questions. And so here is just an example of how experimenting is important as a culture for InterSystems, and how we want to make sure that we try out different things, as I'm sure most of you guys do as well. And of course, manage the hype and bring some cool things, and that they have important impact to you, but also make it fun for us. And so we're going to start with the first use case with Derek.
Hi, so I'm Derek Robinson. I'm a senior technical online course developer in the online learning group. And the use case that I'm going to be going through here is on using generative AI, or specifically ChatGPT, to create video storyboards for our learning catalog. So this is kind of a little screenshot of what we use, which is the custom GPT functionality within ChatGPT. If you haven't seen that, I'll show a little bit of a video during this presentation. But basically, using generative AI to distill large amounts of content to be able to create learning videos for our customers. There we go. So before we get into it, I just wanted to really quickly summarize what our online learning team's workflow is in learning services when we create new content. So at a really high level, you can think of it in 4 stages. We go through a design where we'll meet with stakeholders and figure out what the goal of the content is, what we're really trying to achieve. Then we'll go through writing it, and that's part of what the main crux of my role is as a course developer, is to write out the video script or to write the exercise or whatever the actual content is, to really write out the content. Then we'll go through and review it. So our stakeholders and experts will review whatever me or my colleague wrote to be able to ensure it's accurate and really captures the learning objectives. And then lastly, we will go through production of actually creating the visual media or whatever that is that we're creating for our learning content. So in this talk, in my particular section here, I'm mainly focusing on design and writing, although in the last slide I will have a little bit of a nod to the production side of things as well. So creating a custom GPT is really what the use case is here. By show of hands, how many people have used the custom GPT feature within ChatGPT? Is anybody familiar with this? Okay, just a few. So this very recently became available in the free tier, so you can experiment with this now as part of the free ChatGPT, although it is pretty limited in what you can do with it. But basically what you do is you provide a bunch of instructions to ChatGPT to be able to essentially prepackage a bunch of information in every interaction that you have with it. So rather than needing to load into every prompt and every discussion that you have with the GPT, you basically give it a set of instructions to follow each time that you have an interaction with it. Now, as you're going to sessions this week, you're probably going to see a lot about RAG architectures, about fine-tuning, about pre-trained models and things like that. This is all a very lightweight, not to that level of actual kind of deep learning and things like that with this setup. This is really just the basic out-of-the-box ChatGPT, but you're giving it some custom instructions for your use case. So this is not a RAG architecture. It's just a very lightweight and quickly accessible version. So when it comes to the GPT, we give it a bunch of information. So let's say if our team creates storyboards in 3 columns, so we have narration, visuals, and then in the 3rd column we typically put how does the narration and visuals work together, right? What should the timing be? How should that look on screen, right? And so what we can do is we can add in instructions, and then similarly we can upload documents to be able to say, use these as reference points. So for example, we might have style guides, writing tips, or even sample storyboard documents where in the instructions I might say, hey, use sample storyboards.doc as the guide for what your structure should look like when you create a storyboard for us, right? So giving it a lot of this guidance in the form of uploaded documents. And then ultimately, as I'm going to kind of start this video playing here, really the scenario is giving all this instruction. So what I scroll through here is just the instructions that we've given the GPT to say, hey, follow all these things. Make sure that you get the learning objectives from the user, what the target audience is. And so over here on the left is where you configure how this GPT behaves. So those are the knowledge files that we upload. These are kind of the basic conversation starters, all these things you can prepackage into the interaction. And so then when we pop back over and actually use this, what I'm going to do is paste in here a prompt that we've curated to say this is how we're going to interact with this most effectively. We're going to give it our learning objectives. So by the end of the video, the learner should be able to do these 3 things. The video should be about 3 minutes long, conceptual animation style video. And then importantly here at the end, I say the attached documentation should be used as your reference material. So as we go through, again, not a RAG architecture. It's not actually going to pull this data from anywhere. Just within this interaction, in this case, I give it a chapter of documentation about interoperability productions, and just let it, as a really simple use case, use that. So the scenario here is that if I am brand new to this topic and I need to really go learn about interoperability productions to build a 3-minute conceptual explainer video, I might be able to leverage things that my colleagues have done here. If they've written a 25-page document about interoperability productions, I could go read that myself to learn it, but to get a starting point for a video, I can just drop that in here and let it generate something for me to start from, to be able to generate ideas and have something to work with. So as you can see, it starts to pop out this 3-column format, which is exactly what we create. And of course, I would never use this directly because there's going to be a lot of potentially inaccuracies, gaps, things like that. But it can be really helpful for getting started and having an idea to work with. So some of the key benefits that we observed as we went through this as a team and started experimenting with this approach, like I just said, we can leverage the work that others have created. So being able to say, if someone's already done something, we don't need to reinvent the wheel. We can take what they've done and let that be the starter substance for what we create as a video. We can streamline the consolidation of unstructured content. So taking documentation, maybe taking meeting transcripts, taking Confluence pages internally that we go through with project planning or things like that. Whatever material we want the GPT to be informed with to be able to make an explainer video, we can kind of put that in and let it sift through that. And then ultimately generating interesting ideas for use cases. I think sometimes if we're explaining productions and we say, hey, we really need to think of a scenario here, the GPTs can be really good at coming up with creative examples that can demonstrate that. And then lastly, faster prototypes, of course, getting you a starting point really quickly. Last thing here is a few key lessons learned, which I'll just kind of pop up all at the same time. But basically, sometimes it's more effective to really target what the user is doing one piece at a time. So if I maybe had not as much luck getting 3 columns that were all really good, I might take a step back and say, just give me the narration first, right? I want to generate me a 3-minute narration, and then I'll take that block by block and ask it to help me with some ideas for visuals if I need that, or other ways that we can represent the content. Being aware of what you provide as knowledge. So when I showed earlier uploading the samples and things like that, you have to be very careful to make sure that the GPT knows what it should use those samples for. So if we have one of the scenarios we had a sample storyboard that was about integrated ML, for example, and then when I went to create a storyboard about productions, it started talking about integrated ML in that, right? And so you need to be very specific to say, don't use this thing I uploaded as knowledge, but use it as just a guide for structure. So really depicting in the instructions how it should use what you're giving it. And then also always keeping a human in the loop, right? Never just taking this and directly sending it to the next stage, but making sure that we're looking at it and curating what we get back from it. Last slide here in my section is just a note to the production side, which I mentioned. So most of what we're talking about here is in the script and kind of design of the video, but we've also started experimenting with the latter end of that workflow, which is actually the production of the video. And so, generative AI helping us to create graphics for certain things, to be able to leverage speech to text. So if you're more of a kind of talk it out idea, being able to, just speak your idea and have it capture that as a V1 narration for a video that can be cleaned up and curated. And then also for transcript generation and cleanup of our videos. If we have a video where a subject matter expert might directly present on like a lightboard or a whiteboard style, using generative AI has been super helpful to actually get that transcribed and then make it very seamlessly into closed captioning for that video. So that's all that I have, and I'll pass it off next to Vivian.
Hi, my name is Vivian Lee. I'm a developer on the application services team at InterSystems, and I'll be presenting on a couple ways that we incorporated vector search in a bid search tool and the positive outcomes that came out of it. Right, so for this project, we used vector search to improve the utility of an internal tool that we have for searching and managing past bid responses. And at a high level, we can think of a bid as a questionnaire document that potential customers send to learn more about a company, general information about it, and the solutions that it provides. And a bid response includes answers to those questions so that that company can determine if the products and services that the company offers are the best fit for their business needs. So the outcomes of this project were that with vector search, we were able to obtain more relevant search results for user queries and also help mitigate data redundancy in this app. So next, I'll show a general overview of the workflow for this internal tool. So we start with a set of past bid responses and also question and answer pairs for frequently asked questions that are commonly found in bids. These get uploaded into the internal tool, and when the assigned bid response team queries that tool, it outputs relevant search results that include information that can be used to help answer the questions in the bid and create the bid response. So next, I'll be showing a side-by-side comparison of the top search results that are obtained from our old search method with vector search. And the example query that we have here is, what is the turnaround time for new implementations, such as standing up new pipelines for eligibility, claims, lab results, et cetera, end-to-end from a new health plan? Our old search method relied on the %similarity SQL function. As you can see from the search results here, %similarity search is great at keyword matching. It found search results that included keywords from the query like lab results, claims, healthcare plans. But if you read through these results, you can see that they don't actually answer the question that was asked. So if it finds the wrong keywords, it might miss the mark and not answer the question. In contrast, with vector search, we can capture the meaning and context of the query, and it can output relevant results that are semantically similar to the query. So here we see the top results include examples of an implementation that took less than 9 weeks, or an example of how health share typically culminates in a 6-month release cadence. These results are much more relevant and can be used to help create better bid responses. So next, I'll show how we extended the use of vector search to not just improve the relevance of search results in this tool, but also to help mitigate data redundancy in the app. And here we did this on the FAQ page that shows the question-answer pairs for common questions found in bids. Oh, okay. Sorry. So because multiple people are working in the app at the same time, they might be on different sales teams and working in different regions, it's likely that duplicate data would be unintentionally inserted in the application. Previously, the way we handled this was that we would prevent inserting duplicate questions that were exact text string matches. But we know that there are multiple ways that a question can be phrased to essentially ask the same thing. So with vector search, we can also prevent inserting semantically duplicate questions. Right. So next, I'll show a demo of how this works. First, we start off with an example of the search results from vector search. So here we have the query, how does your solution improve quality of care? And with vector search, we can find that there exists 2 questions that exist in our database that are semantically similar. Talk about care gaps or describe how solutions can help improve quality of care. And I'm just going to copy that text for the next part of the demo, which froze. Oh, okay. So say that the user first started from the questions page. As you can see here, there are dozens of questions in this table. And the user might not have time to read through all these questions and might miss that question has already been answered. If they go to enter the question, first we paste exact text, and we see that there's form validation that tells us that this question already exists. But if we were to ask that same question in a simplified, different way, like before, how does your solution improve quality of care? By adding vector search to this form, we can see that we've identified 2 potential duplicates so that the user can be warned and not unintentionally insert duplicate data. Or they can go through that process and determine from themselves that this question is distinct enough and not heed that warning and then insert the new question. Okay, so next here I show a step-by-step guide on how you can easily incorporate vector search into your app. And this is easily achievable with apps running on InterSystems Iris 2024.1. As you can see here, it's achieved in a few steps, which I won't go into detail here, but I did include in the slides so that you can read at your convenience. So as a recap, by incorporating vector search into this app, we were able to obtain more relevant search results for user queries. Users could now input more conversational queries or even copy and paste questions from bids directly, rather than limiting their searches to a few keywords. I also want to highlight that this would help being able to find more relevant content faster would also improve the turnaround time for generating bid responses. And it's great that we can create bid responses faster, maybe respond to more bids, but also this has a positive outcome for the people involved in the bid response process. And it helps reduce stress for both the authors that are responsible for answering those questions and the reviewers who can determine if those questions are factually correct and ensure like correct grammar and writing style before those get sent out to customers. We also saw how vector search could be used to facilitate data management in an application that is used by multiple users and increases collaboration. So yeah, if you are interested in learning more and want to see a more technical behind-the-scenes view of this work, I'll be presenting tomorrow at the Tech Exchange at 1:30, and would love to see you there. Next, I'm going to hand it off to Chris. Tom. Yeah.
Thanks, Vivian. Okay, so I'm going to talk about a customer support assistant that we've kind of built as part of our innovation program internally. So this is part of the pitch that we made internally. Really, it's about taking all sorts of information, internal information that InterSystems has access to, and exposing that in a very friendly manner. Of course, Lliopoulou, this image made by Midjourney, another generative AI. So of course, the whole thing is about generative AI, doing support better using tools that we can get. So taking that very broad vision of having a very knowledgeable assistant for all of InterSystems' internal information, and then boiling it down to something that we can bite off a little bit and act on. We started with TrackCare, which is our EMR product that's sold outside of the US, and we just took a very small number of service tickets, and we had to de-identify those tickets because often people put a bunch of information when they have a problem. They're just entering information that they know about this problem, and okay, so it's an EMR. It's a medical records product, and it might be a doctor that is having an issue with this, and they're going to say, you can see my patient record is not right, and they may paste that right into the support thing. They're not necessarily supposed to, but that kind of data cannot get out and can't be used for purposes that it was not intended to. So we had to go through a very extensive data cleaning process. We also implemented it on Google Cloud. At the time that we started, we didn't have Iris vector search, so I used Google Cloud Platform for this. And that was very nice from this perspective. So this is the tech stack that we started with. Really, it's just, we had a Python, a Jupyter notebook to run it. But all of the stuff in Google Cloud was fronted. So Google Cloud has services. They have a vector search service. They also have large language models that we're using. But they provide Python connectors. And that way, in the future, we can switch out and use different tools, such as Iris vector search for this, for some of these pieces. On the left, you see the ingestion. You have to take all the documents, split them up into small chunks, make vectors out of them. Those are the vectors that Vivian was talking about, that you can get really good search and semantic search. But overall, this is really just kind of a search, find related things, summarize it, and just answer. That's not quite what the full vision of Lliopoulou is, which is more intelligent than that. And so we switched to using more of it's called React is the pattern. And it's really just a looping of where the large language model first does some action based on the question. It gets some information back from tools that it uses, and in this case, querying documents or querying tickets. And if it gets a good enough answer, it'll answer. But it'll also try another couple times of taking the information that it's gotten so far, all of the information from the conversation, and then deciding what to do next, what type of query. So that can change each iteration of the loop, and it gives it a lot more intelligence. And that's something that's built into LangChain which is the Python library that we're using. So that really helps improve the abilities of the chatbot, and we'll continue to iterate on that going forward. So overall, we ended up getting a user interface that Chris is going to talk about, and we have a nice roadmap for all of the different stages that we're going to go through going forward, and hopefully get executive sponsorship for continuing this work.
Hi everyone, I'm Chris Stewart. I'm a Principal Technical Specialist for InterSystems. I work in our track care side of the business. As I think Tom mentioned, that's our EMR. I'm also responsible for development of iService, which is our support platform for the healthcare side of the business. If you're familiar with WRC, it's our WRC for healthcare. It's going to be difficult to ignore that there has been an explosion in the availability of models. Models are everywhere. They work on text, they work on language, they work on visuals. How can we use them? We already talked a little bit from our previous speakers about, for example, Tom mentioned de-identification. That used a model. So we've talked in sort of the high level here of our LLMs and RAGs. If I've got an Iris application, as I do, how can I start using this sort of stuff now? Do I need to go at the big level of implementing React or RAG? No, I don't. So we've got lots of these modules. We've got modules that can do all sorts of things. They're very easy to use. How do we bring them together? Well, we use interoperability. It's built into the platform, and it enables us, along with the new support for embedded Python, to start bringing these into our existing code base in an easy manner. We don't have to do massive re-engineering. It also gives us some other stuff as well. It gives us queuing built in. It gives us caching. We are able to have pooling of our resources. And all that stuff is just, we get that for free. We also get very easy testing. Interoperability allows us to test each part in isolation. It enables us to test chains. It's very, very easy to get at. It gives us auditing. The flow control is very easy as well. We've got visual builders. We can build in code. We can put all these together in a logical way that's easy to understand and very modular, and really enables reuse of code as well. So by using this, we've also got access to all the stuff that interoperability provides. For example, adapters, we're able to read files very easily. We're able to read from sockets, from HTTP. We get all the benefits of interoperability and all the benefits of Python all together in one. So one of the use cases we've got as part of our chain when we were de-identifying documents was TrackCare is a global product. We support in many regions. Our support needs to deal with many languages. So one of the first steps in our chain when we're working with this is we need to know which language we're working with. We have a library called FastText, LangDetect, and if you feed that in a text sample, it will give you back its predicted language. French, English, so on. We can then use that to determine how we're going to process it and chain together stuff so that we can start working on our de-identification. So there's some code here, which can be a little difficult to read off of a file, but the top section there is our Python file. What's maybe not very clear for the people at the back is that this is actually a .py file on a file system that is not part of, it's not imported into Iris. We can use Python files as they come. We do that by our Python init code here, and we just import the libraries we need. We import LangDetect, which is the section up at the top, and then we can just have that as part of our Iris process. When we're setting up our ensemble operations, we're then able to call in to our language detection here, which is our method there. We're able to call into that almost as if we're calling Iris, and then we can pass that back up through the chain, get the language, and incorporate that into a business process. Our business process here, this is one of the ones we're using for identification. I don't like the way I've done this slide because I'm starting from the right and coming to the left, but you can see here on the right, we have a lot of operations here that do a lot of different things. So we have something that can detect a language. We have a bunch of translations at the bottom. So if there's a language that we have a model for, and there are models available to translate Spanish to English, French to English, and so on, we can take that result, redirect it, get the English back. We're then going to pass it to our de-identification model. That's one that Stanford produced. You're able to feed in text. It was trained on COVID radiology data, and that will tell you, here are the elements within that I think are potentially patient identifiable. It'll pick up names, healthcare workers, dates, IDs, telephone numbers, a bunch of other things. It'll pass out those positions. I do not know why this is auto-scrolling. I'll come back here. So I've got just a part of our business process here. So you can see we're getting the question, we're deriving the language. If it's French, translate it. You can kind of imagine where it's going from there. And this is the end result. This is one of our workflows. This is a truncated one. This was actually English text at the top. So you can see here, one of our users has pasted in something with quite a lot of privileged information. You can see they've got my name in there. They've got an ID, not a real ID, just for example. They've got dates. They've got mention of the hospital, where the labs are at. They have got the name of a doctor. They've got a phone number in there. So the first thing we've done is we've identified this as English. If this was, for example, French, we'd then pass it to our service to translate French to English, pass that down. We then get the raw results of the de-identification model in that next line. That's actually not in a very useful format for us. So it then gets passed to another operation. This operation's written natively in Iris. We aggregate it, we parse it, we summarize it, and we pass it out. So we're very easily able to mix Iris and Python pretty much seamlessly. If you weren't looking at the code, you wouldn't necessarily know which one of these are Python and which one are Iris. And you can pass back and forward. And then at the end, having done all that, we get our positions, we pass back to an Iris process, and we get out our redacted text. So you can see here where we had names and IDs at the top. Those are now blanked out. We have got the mention of the hospital blanked out. We've got the mention of the doctor's name blanked out. We've got the phone number blanked out. So we've now got nice, clean data. And this being interoperability, we could then send this on to somewhere else very, very easily. That's just another link in the business process. So this was not meant to be a animated slide. So yeah, adding new steps to this is very easy. For example, one of the use cases we've been looking at are identification of terms that may indicate a clinical risk. So if we've got a model in there, we could detect if it meets a level of confidence. We can quite easily put an ensemble business operation in that can, for example, when we have this set up already, can ping a team's webhook, and that will alert that team automatically. There's no need to start playing with spaghetti code and trying to work things in. It's just part of the interoperability. The platform does the work for you. And also, it enables very easy reuse. So we have got many different use cases where we might want to know what a language is and whether or not we want to translate it to English. We're able to reuse those in as many flows as we need. We define it once, we reuse it again and again. It's also very easy if you're, for example, have an application that exposes a REST API. It's 2 lines of code to start calling into this, the production. Call it synchronously, ask your question, get your answer. It's gone through Python, it's gone through Iris, it's used models. But you've not had to substantially change your application. You've made the call, you've got the call. It comes back very, very easily. So it's very easy to start implementing these smaller use cases and start adding the power of these pre-trained models into your application. So yeah, the takeaway I'd say here is it's easier than you think. You can get this into your existing application with basically no need to make any substantial changes. You just need to call into it. It may be harder than you think. Some of these models are very, very resource heavy, especially if you're using a CPU. ideally check with the model. Having a GPU could be of a benefit. But yeah, there are many, many models. It's very, very easy to have a play with this. I encourage everyone, just go and experiment. And thank you for your time. Back to Alki.
All right, so we took 20 seconds more than we wanted, but the floor is yours. So we have almost 15 minutes time for questions.
I have a question about the de-identifying dates, which I understand, the specific date and time may not be relevant, but in this case, there was 2 dates that were 4 months apart, and what's relevant is that there was this 4-month gap. Is there a way to de-identify dates such that you maintain that piece of information?
So in that case, that's just the output of the model.
Yeah.
It's doing dates. Now, you kind of hit on this there. Dates are a really special case because a date can be date of appointment, it can be date of sample, it can be your date of birth. 2 of those can't really be used to identify you. 1 of them absolutely can. So you may need to do some extra processing there. One of the things that comes out of the model is a sort of confidence score, and the positions all come out. So it is possible to start trying to build some more rules around that. But all this is doing is, here's an input, and here's where I think these classes of information are, and one of those is dates, which again is very context sensitive.
Hi, I'm not sure this is out of box question. So these AI mostly like predictive suggestion on the use cases, right? So anything that's something related to developer friendly, like a code base, code build, something like that. I mean, AI can suggest, if I feed my code, it can suggest any errors or I can fix. Or if I give the specific use case, it will build an adapter, something like that.
No, none of these things were kind of focused on the code generation. There's some efforts internally to work on some things like that, but we don't have much to announce about that. But it's definitely something that's of great interest to people within InterSystems. And there is like one kind of exception to that. We're talking about a DTL generator assistant that we've been developing that we're showing some previews of. So that's data transformation language, it's message-based, and we're developing a model to assist with that and actually have a service to help people that are developing those transformations.
So I work for an healthcare, and we deal with a lot of clinical data. That's something, anything that I can feed this data and get some outcome out of it.
Well, that's it's not geared for that kind of use case. It's more about just helping you code, so you can chat with it and talk about what transformation you want. Just HL7 messages about translating from one format to another or doing some kind of transformation, and that's what the DTL assistant is about.
But come find me afterwards and we can talk more.
Sure, yeah.
I'm still trying to figure out what's local and what is actually going out to the services and stuff. For what you showed here, was that services that you were importing, darn it, module the Python modules and stuff, and at some point you were actually, because in your example you were cleaning the data for the PHI. So was that cleaning being done with modules that were local, or was that or was data getting uploaded somewhere, the work being done on someone else's hardware, and then getting the results back? Or
yeah, that's an excellent question that I was meant to mention in the context of that. So yeah, it's all local. These are Python modules. They're available. The step that I did miss off that is you do need to install them. The instructions are in the documentation for Iris. But once you have installed that once as Python, it is local, the model is there, it is not going out to cloud. And that's kind of where the power is, that you're kind of creating your own cloud of microservices with this. sorry, lost it there. Yeah, so it is, if you're not going for the sort of larger scale use cases at first, it is still easy to just take a couple of models, slam them into interoperability, and you have access to them. They're there. Again, just a warning at the end, resource can be a thing in some of these. Some of them are very, very expensive to run. So you don't just put them in production without checking their resource requirements. A GPU may help. But yeah, no, these are all local. They're running on your Iris instance. Yeah, I mean, if you can do it in Python, you can integrate it basically. So that's kind of the takeaway. And a lot of these, you can just take the module as it's written, import it, use it. The details are in the slides. You can get primitive values back very easily. If you need complicated, then JSON is an ideal fit for that. You can get very, very rich data sets back very easily in JSON. Iris can also handle JSON incredibly well. And that's basically the way to do the interchange. You can kind of make it as simple or as complex as you need it to be.
All right.